Test Thursday is on 1.1 through 1.5, so this is the test review. I'm going to do all the questions from the review, so it may be a little lengthy, but you guys can always skip through it if there's a section that you already understand or not. So, starting with number 1, determine the domain, range, and intervals of increasing, decreasing, and constant. So domain and range, domain is the x values, range are the y values, and then intervals of increasing, decreasing, and constant, we only look at the x values, and it's always, always, always parentheses for these. So looking at A, so starting with the domain, we move from smallest to largest. So we start all the way to the left. Our smallest value here for our domain would be -5. And because that is a closed circle, we put a bracket because it's including -5. And then that little piece of our graph stops at 1, but it also picks up here at 1. So we don't have a gap here because 1 is included. It's included in that top circle there for the first part. So we don't have a gap, we keep going, and then our graph stops at 6. And again, it's a closed circle, so we put a bracket. Next, we can find our range. So we start at our y values. Our smallest y value is -4. And because it's an open circle, we put a parentheses. And then our graph keeps going, going, going. All the y values are included until we get to 16. And that's a closed circle, so we put a bracket. Next, let's find where our graph is increasing. So our graph would be increasing from 1 to 6, because remember, we ignore the y values for increasing, decreasing, and constant. We're just looking at the x values. So from 1 to 6, and it's always parentheses. So 1 to 6, we're increasing. And then we would be decreasing from -5 to 1. And then we're not constant anywhere. Next, for B. So let's start with our domain. So our graph points forever in the left direction, so that would be -infinity. And again, when you do -infinity or positive infinity, it's going to be parentheses, so you don't use brackets with those. And then moving to the right, still looking at our x values, our graph is going forever in the left direction, so that would go to infinity. And then for our range, we start down low, so our graph is pointing down, so that would be -infinity. And then the highest point our graph reaches is this one, which would be 4. And that's not an open circle there, so we put a bracket, including that point 4. Next, for increasing, we are increasing. So increasing, decreasing, constant, we move from left to right, so I am increasing as I go up to 0. We ignore the y values, so it would be -infinity to 0 with parentheses. And then we are decreasing from 0 to infinity. So even though this arrow points down, people might think that it goes to -infinity because it's pointing down, but it's going to the right direction, and we look at the x values. So it's going to infinity. It's going in the positive direction. And then we are not constant anywhere. All right, now let's look at C. So we're going to start with our domain. So our graph points forever in the left direction, so that will be -infinity. And then our graph stops at the x value of -1. and that's an open circle, so we would want to put a parentheses. And then our graph continues at 1, and again it's an open circle, so I put a parentheses, and goes forever in the right direction, so it goes to infinity. Next, for range, so we start down low. Our graph starts at 0, so when y is 0, and those are open circles at 0, so it would be a parentheses. And then our graph points forever in the up direction, so we go to infinity. And then next we have increasing. So we move from left to right. So if I start at the left here and go to the right, this is going down, but the right arrow is going up. So we are increasing from 1 to infinity. Because we ignore the y values, we only look at the x values. So we are increasing from 1 to infinity. And then we would be decreasing from negative infinity to negative 1. And then we are not constant anywhere. And then lastly for D, so let's start with our domain. So our graph's smallest x value is -2, and that's a closed circle, so we would put a bracket. And then our graph stops at 6, our largest x value would be 6, and that's an open circle, so we put a parentheses. Next we have our range. We start down low and go up, so our graph starts at 2, at the y value 2 here. And it's not an open circle there, so we would put a bracket. And then our largest y value would be 8. Even though this one has an open circle, the dot on the left is closed, so we would include 8. So because this is closed circle trumps the open circle, so we include 8 with a bracket. Next, we have increasing. So we're increasing on the right side, so that would be, 3 to 6. We always put parentheses with increasing, decreasing, and constant. Next, we have decreasing. We're decreasing from -2 to 1. And then we are constant from 1 to 3. Next, we're going to be graphing the piecewise function. So in graphing piecewise, you always want to do one piece at a time. So we'll start with the first piece. And then we always want to start by plugging in the number that it gives us. So I'm going to start by plugging in -4. So I have -4 plus 5, which would be 1. So I plugged in -4 for x and got 1 for y. So the point I'm going to graph is -4, 1. And when it is a less than or equal to or greater than or equal to, we put a closed circle. If it was just less than or greater than, we would put an open circle. So at this point, I'm going to put a closed circle because it has that equal to. So I'm going to go to the left to -4 and go up 1 and put a closed circle. Then I need to plug in another point to tell me the direction that this is going in. So I need to plug in some value for x that is less than -4, so I could plug in -5. So -5 plus 5 would be 0. So I plugged in -5 and got 0. So the second point just tells me the direction. It's just showing me which way my arrow is going to go. So I'm going to go to the left to -5, stay on 0, and just start at the closed circle. We start at the first point. That's our starting point, and the arrow goes through the second point. A lot of people on the quiz were putting arrows through this point too, but that's not right. It starts at the first point that we plugged in and then goes through the other one. just a line pointing down to the left. All right, so let's do our next piece. So I'm going to start by plugging in -4. So I have 3 times -4 minus 4. So this would be -12 minus 4, which would be -16. So I plugged in -4 and got -16. And this is going to be an open circle because it's just a greater than. So I'm going to go to the left to -4 and down -16, which is going to be off of our graph. I'll put it down here, and it's an open circle. Next, I want to plug in a number that satisfies this, so any value for x that is greater than -4, so I could plug in 0. So I have 3 times 0 minus 4. This would be 0 minus 4, which is just -4. So I plugged in 0 and got -4. So I'm going to stay at 0, go down to -4. The second point just tells me my direction. So I start at the first one and go through the second point. That's my second piece. So that is my piecewise function. For the next piecewise, start with our first piece. So I'm going to start by plugging in -1. So I have 3 minus -1. Be careful when you have two negative signs. Just make sure you are careful. Minus a negative turns into a plus, so this would be 4. I plugged in -1 and got 4. And at this point, I have a closed circle because it's less than or equal to. So I'm going to go to my graph, go to the left to -1 and up 4, and put a closed circle. So that is my first point. Now I'm going to plug in another value for x that is less than -1. So I can plug in -2. So 3 minus -2 would be 5. So I plugged in -2 and got 5. And I go to the left to -2, up 5. Remember, the first point is where we start our line. The second point is what we go through. It tells us the direction. So I start at the first point, go through the second one. So that is our first piece. Now let's look at the second piece. So we're going to start by plugging in 1. So I have 1 squared plus 1, which is 2. So I plugged in 1 and got 2. So my first point is 1, 2. And this would be an open circle because it's just greater than. So I'm going to go to my graph, go to the right 1, up 2, put an open circle. Now I can plug in any value for x that is greater than 1, so I'll plug in 2. So I have 2 squared plus 1, which would be 4 plus 1, which is 5. So I plugged in 2 and got 5. So I'm going to go to the right 2 and up 5. Now the first point is where I start my line. The second one is just the direction. So I start at that open circle and go through the other one. The second point is not also open. Only the first point is an open circle. And the second point just tells us which way our arrow is pointing, which way our line goes. There's our second piecewise. All right, number 3. Determine if the function is even, odd, or neither. So here we can plug in a number and its opposite. And if they are the same, if we get the same answer, that means that they are even. If we get opposite answers, that means that they are odd. And if we get different answers, that means that they are neither. So 2 and negative 2 always work. It'll probably be like the easiest ones to do with the math, but sometimes you may want to plug in a different number other than 2 and negative 2. Like if you had a square root, you may want to plug in 4 and negative 4 because you can take the square root of 4, but you couldn't take the square root of 2. So that's just an option there as well. So let's plug in f of 2 and f of negative 2. So I have 2 minus 7 times 2. This is 2 minus 14, which is negative 12. When we plug in negative 2, I have 2 minus 7 times negative 2, which would be 2 plus 14, which is 16. So these would be neither. For B, again, we can plug in 2 and negative 2. So I have negative 2 squared minus 2. That negative is on the outside. So this would be negative 4 minus 2, which is negative 6. And for the next one, I have negative 2 squared minus 2. So we can't make this a positive. You have to square it first, and then that negative stays on the outside. So negative 2 squared would be positive 4, and that negative stays on the outside. So it's negative 4 minus 2, which would be negative 6. So since these are the same, this would be even. And then for C, I see that I have a cubed root, so thinking about it, I know what the cubed root of 8 is, and that would be 2. So I want to make the inside of this 8 when I plug in my numbers, or I could make it 1 by plugging in 2, which would work also, but again, you could plug in anything. So I'm going to plug in 9, because I know that 9 minus 1 would be 8, and I can take the cubed root of 8. So that means I also have to plug in negative 9. So I have the cubed root of 9 minus 1. So the cubed root of 8 would be 2. And then the cubed root of negative 9 minus 1, which would be negative 10. And I can't take the cubed root of negative 10, so these would be different numbers, different answers. So this is neither. All right, next, we have a composition function. So I'm given f and g of x, and it asks me to find f plus g of x. So f of x is 7x minus 6, and then I'm adding g of x to it, which is 4 minus x. So when adding or subtracting or multiplying, we just want to make sure we combine our like terms. So I have 7x minus x, which would be 6x, and negative 6 plus 4 would be negative 2. So this would be f plus g of x. For b, we're subtracting. So f minus g of x, we have 7x minus 6 minus g of x, which is 4 minus x. So I put the second one in parentheses because when we subtract, I have to make sure I distribute that negative. So 7x minus 6 minus 4 plus x. So combine my like terms. This becomes 8x. Combine negative 6 minus 4 would be negative 10. And then I'm going to plug in 0 because f minus g of 0. I find f minus g and then plug in the number. So this would be 8 times 0 minus 10, which is 0 minus 10. So that is just negative 10. So f minus g of 0 is negative 10. and then f minus g of x is this one. For c, we have to multiply. So I have 7x minus 6 times 4 minus x. So because I have a binomial times a binomial, I have to FOIL. So start by multiplying the firsts together. So this would be 28x. Then the outsides, so minus 7x squared. Then the insides, so this would be minus 24. And then the last one, so plus 6x. Combine the like terms, so I start with my highest degree, which would be negative 7x squared. Then I have 28x plus 6x, so this would be plus 34x, and then minus 24. And then lastly, I'm dividing. So this would be 7x minus 6 divided by g of x, which is 4 minus x. Whenever we divide and we have an x on the bottom, we have to state our domain because the denominator cannot be 0. So just set the bottom not equal to 0 and solve for x. So I would add x to both sides. So this would be 4 does not equal x, which is our domain. So our domain is x does not equal. So we just have to add that restriction there. So not only is our answer 7x minus 6 divided by 4 minus x, we have to include the domain, which is x does not equal 4. All right, number 5, we're doing the same thing. So first we want to add our two functions together. So x squared plus 3 plus the square root of 7 minus x, because g is all under that radical, because g is the square root of 7 minus x. We can't simplify anything here. We don't have any like terms, so this is our function. For f plus g of 3, we want to plug in 3. So I have 3 squared plus 3 plus square root of 7 minus 3. So 3 squared would be 9 plus 3 plus the square root of 7 minus 3, which is 4. So 12 plus the square root of 4 is 2. So this would be 14. Next, we want to subtract them. So I have f of x, which is x squared plus 3, and minus g of x, which is the square root of 7 minus x. And we just leave it like that. Can't simplify here. So that's all. For c, we are multiplying. So I have x squared plus 3 times the square root of 7 minus x. We can't FOIL this out or anything because that second term is just 1, so we would just leave it like that. For d, we're dividing. So we have x squared plus 3 divided by the square root of 7 minus x. And again, whenever we divide, we want to check our domain in the bottom. So I need to set the denominator not equal to 0. So I could square both sides. So I'm just going to rewrite it down here. So I would square both sides to get rid of that square root. So 7 minus x is equal to 0 squared is still 0. So it does not equal 0. Then I can add x to the other side. So 7 does not equal x. So in my answer, whenever I divide, I also have to state my domain. So x cannot be 7. I also have a square root on the bottom, so x can't be a number that'll make this square root a negative, but we'll get to that in the domain here, because this question's a little bit more specific, so it's asking for the domain of f divided by g of x, so that would be x squared plus 3 over square root 7 minus x, which I just noticed I forgot to close the parentheses here, but it doesn't really matter, you don't need the parentheses on top, so if you didn't put them, that's fine too. Alright, so let's check our domain. So for the domain of a combination function, we want to check the domain of f, the domain of g, and then the domain of the whole thing, f divided by g of x. So let's check our domain for f. So our f of x domain, I have x squared plus 3. There's no number that I can't plug in here. X squared, our domain is negative infinity to infinity. We can plug in whatever we want. It's all real numbers. We don't have a restriction on x. Now let's check our g of x domain. So g of x is a little bit more challenging because I have the square root of 7 minus x. When you're dealing with square roots, you cannot have a negative. So we would set what's inside our radical greater than or equal to 0. So 7 minus x is greater than or equal to 0. Add x. So 7 is greater than or equal to x. So x has to be something that is less than 7. Also, we have to check our domain of the whole thing here, which because it's a fraction, I can't have 0 in the denominator, which I just found kind of here in doing the same work. So I would just set the denominator not equal to 0. I also did that in D in the last part. So I would square both sides and add x to the other side, so I would get x cannot equal 7. So these are my 3 domains for each part. I have to check f, g, and the whole thing. So I'm going to put them on a number line and see where they overlap, and that is my domain for the whole function. So here's my number line. I start with 0. I'll have 7 here. I'll just put negative 7 over here. So domain of f is the whole thing. Negative infinity to infinity, so every number is included. The domain of g is x is less than 7, so we start at 7 and go down. And then the domain for f divided by g of x is just x cannot equal 7, so we have a whole at 7, but it includes everything else. So here, where it overlaps would be these 2 lines. So it is from negative infinity. Now we can't include 7 because we said here x does not equal 7. So it could equal anything else, just not 7. So I would put 7 and put a parentheses because this means that it is not included. So my domain for the entire function is negative infinity to 7. Okay, next we have composition functions. So we could either see it this way where it says f of g of x, or we could see it written like f of g of x. So these mean the same thing. No matter what, we always want to take what's on the inside and plug that whole function into the one that's on the outside. So I'm taking my entire function g and plugging it into the x in f. So I have the cubed root. Where I see that x is where my g function is going to go. So x cubed plus 1 minus 1. And now I can simplify. So the plus 1 and minus 1 will cancel out. So then I have the cubed root of x cubed, which the cubed root and the x cubed will cancel. So then I'm just left with x. So f of g of x is just x. Next, we're doing it backwards. So we're plugging in g of f. So we want to start with the inside. Plug that into g. I'm going to start with f. Plug that into g. So this would be the cubed root of x minus 1 cubed plus 1. Again, we can simplify. So the cubed root and the cubed will cancel. So this is x minus 1 plus 1. And then the minus 1 and plus 1 will cancel, so then I'm just left with x. So g of f of x is x. Next, we have f of g of 0. So f of g I just found up here. We know that f of g is x, so this is just telling me to plug 0 into x, so then my answer here would just be 0. Another way we could do this one would be take 0, plug it into g. Whatever we get for that answer, we would then plug that into f. So if I plug 0 into g of 0 would be 0 cubed plus 1, which is just 1. So then I would take 1 and plug it into f, so now I'm finding f of 1. So this is the cubed root of 1 minus 1, and 1 minus 1 would be 0, and the cubed root of 0 is just 0. So you can do it either way. You can plug it in. Once you already find the composition function, you could just plug the number into there, or you can plug it into the one on the inside, take that answer, and then plug that into the x's on the function on the outside. All right, verse 7. So here we have to find f of g of x. So I'm going to start with the inside and plug that one into the function on the outside. So take g, plug it into f. So 1 over x cubed. So this would just be 1 over x cubed. Because 1 cubed, if we distribute this, 1 cubed is just 1, and then x cubed is x cubed. All right, next I have g of f. So I'm going to take f now and plug it in to g. So this would be 1 over x cubed. For c, it asked me for f of g of 0. So that would be my function here. So I have 1 over x cubed. Plugging in 0, it would be 1 over 0 cubed, which we could say does not exist, or undefined, because we can't have 0 in the denominator. So our answer here would be does not exist. The question also asks us to find the domain of f of g. So when we're looking for the domain of a composite function, we always want to check the domain of the inside and the domain of the whole thing. So let's find our domain for g of x. So g of x is 1 over x. The only restriction we have here is that the denominator cannot be 0. So the x in the denominator cannot be 0. So x cannot be 0. It can be any other number except 0. So on my number line, I'm going to start with that. At 0, I'm going to have a hole there, but every other number works. And now we want to check our domain for f of g, so the function we have here. So f of g of x was 1 over x cubed. Again, whenever we have a fraction, we want to set our denominator not equal to 0 because we can't have 0 in the denominator. So I could take the cubed root of both sides and we'll get x does not equal 0. So again, it can be any other number. I just have a hole at 0. So now I look at what's overlapping. So it's all the numbers less than 0 and all the numbers greater than 0. And then we can write that as an interval. So our domain would be negative infinity to 0, but we put a parentheses because we're not including 0. And then again, we would put parentheses 0 to infinity with a parentheses. So this means that we go everything up to 0. It can be 0.00001. Any number up to 0, it's just not including 0. So that's why we put the zeros there, but with parentheses, because that just means that it's not included, but we're including everything up to that number. For 8 and 9, these are a review of what we did in 1.1 and 1.2, what we had on the first quiz. So you have to know your distant, midpoint, and slope formula. So our distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. And I'm going to label my points as x1, y1, x2, y2, just to make it easier to plug in. So I have the square root of 8 minus 0 squared plus 4 minus negative 4 squared. So this would be 8 squared plus, when we subtract a negative, it turns into a plus, so here this would be 8 squared. So then we have the square root of 64 plus 64, which would be the square root of 128. And then we can break that down and simplify it. Because it's an even number, I know 2 is going to go into it, so 2 and 64. 64 I can break down into 8 and 8. Once I have a pair, I can stop there and circle the pair, and whatever I circle will come to the outside. So 8 is going to come to the outside. 2 doesn't have a pair, so that has to stay on the inside. So here this breaks down into 8 square root 2. For the midpoint, our formula is x1 plus x2 over 2, comma, y1 plus y2 over 2. Now the midpoint is a point, so when you list it, make sure you put it in parentheses. So let's plug in all of our values. We have 0 plus 8 divided by 2, and y1 is negative 4 plus 4 divided by 2. So here we have 8 over 2 and 0 over 2, which simplifies to 4, comma 0. So our midpoint is 4, 0. And then lastly, let's find our slope. So our slope formula is y2 minus y1 over x2 minus x1. So this would be 4 minus negative 4 over 8 minus 0. So on top, this turns into a plus. So we get 8 over 8, which simplifies to 1. So our slope would be 1. All right, next for 9, we're determining if the lines are parallel, perpendicular, or neither. So parallel, they're going to have the same slope. Perpendicular, they are going to have opposite reciprocal slopes. So looking at A, we want to put this into slope-intercept form. So y equals mx plus b. That way, whatever is being multiplied to the x is our slope. So I'm going to subtract the 5x over. So y equals negative 5x plus 9. So our slope here is negative 5. And then similarly, in the next equation, I'm going to add 1 to the other side. So here I have y equals 1/5 x plus 1. So my slope here is that 1/5. So -5 and 1/5 would be opposite reciprocals. So these are perpendicular. And then B, so it gave us 2 points for each line, so we just want to use our slope formula to find the slope of each. So for line 1, our slope formula is y2 minus y1 over x2 minus x1. So I'm going to label my points x1, y1, x2, y2, and plug them in. So 4 minus 4 over 2 minus 0 would be 0 over 2. So here I have a slope of 0. For my second line, I have x1, y1, x2, y2. So plug them in. This would be 8 minus 2 over 3 minus 3. So this is 6 over 0. I can't have 0 in the denominator, so this would be an undefined slope. So my two lines, if I were to draw them, the first one has a slope of 0. It's not going to be at the right spot on the graph, but let's just say it's up here. And then the second one has an undefined slope, so it would be a vertical line. So if I have a horizontal line and a vertical line, these meet at a right angle, so these would be perpendicular. So having a slope of 0 and undefined, these two lines are the one exception to the opposite reciprocal rule, because even though they're not opposite reciprocals of each other, they're still perpendicular. All right, next for number 10, we're finding the average rate of change over the function of the given interval. So again, average rate of change, we're using the slope formula. So that would be y2 minus y1 over x2 minus x1. So it gives us two values for x. We want to find the corresponding y's to go with those. So I'm going to plug the x's into the x of my function. So first I'm going to find f of -2. So that is 5 times -2 to the 4th power minus 2 times -2 plus 3. So 5 times 16 plus 4 plus 3. 5 times 16, do it on the side here. So this would be 30. 5 times 1 is 5 plus 3, would be 8. So 80 plus 7. So this would be 87. So when I plug in -2, my y value is 87. And then I'm going to do the same thing, but plug in 1 this time. So f of 1 would be 5 times 1 to the 4th power minus 2 times 1 plus 3. So 5 minus 2 plus 3. So this would be 6. So my y2 is 6. So now I'm going to plug all of these into my slope formula. So 6 minus 87 over x2, which is 1 minus -2. So this would be -81 over, this turns into a plus, so over 3, which actually simplifies to -27. So our average rate of change is -27. For 11, we're finding the zeros of the function. So here I plug 0 into my y, or my f of x, and I solve. So in a function like this, I would want to see if I can take out any greatest common factors. These are not all divisible by 2, so I would have to factor by multiplying the first times the last. So this is -60. Two factors of -60 that add to -7 are 5 and 12, and it would be a -12. So this would be x plus 5, x minus 12. Divide both of our values here by 2. If it's not divisible and we can't simplify, you move that 2 in front of the x, so it'll be 2x plus 5. If you can simplify, simplify, so this would be x minus 6. And then we set both of our little equations here equal to 0 and solve. So I would subtract 5 on both sides, so negative 5 is equal to 2x, divide by 2. So x is equal to negative 5 over 2. And then with my second equation, I add 6 to both sides, so x is equal to 6. So my two zeros are 6 and negative 5 over 2. For B, whenever we have a fraction, all we need to do is set the numerator equal to 0 and just make sure that that value exists with our denominator. So here I have x minus 4 is equal to 0. Add 4 to both sides. So x is equal to 4 is our 0. I just want to double check that this is okay, so I plug in 4 into my denominator. So 9 times 4 squared minus 4, this is not 0, so we are good here. Next, for C, again, I set my y to be 0, or that f of x to be 0, and solve. So I'm going to add 1 to both sides. So 1 is equal to the square root of 2x. Next, I want to square both sides, so cancels out that square root. 1 squared is just 1. So 1 equals 2x, divide by 2. So x is equal to 1/2. For D, whenever you have 4 terms, you want to factor by grouping. So we group the first 2, group the second 2. Find if you have any greatest common factors in the first group. So I would take out 2x squared. So when we divide both of these by 2x squared, we're left with x minus 5. And then I want to take out my greatest common factor from the second group, but I need that parentheses part to be the same. So I'm going to take out a negative 3. So I'm left with x minus 5 again. So I want these two to be the same when we're factoring by grouping. So then I take the first 2, put them in the parentheses together. So 2x squared minus 3. And then the second 2 go in one parentheses together. So x minus 5. And then again, I set both of these equal to 0 and solve. So I'm going to add 3 to both sides. So 3 is equal to 2x squared. Divide 2 on both sides. So x squared is equal to 3/2. I just switched places. So I put x squared on the left. But if you want it on the right, that's fine too. And then the last step is to take the square root of both sides to get rid of that squared. Anytime we take the square root of both sides of the equation, we have to make sure we include that plus or minus sign. So this is plus or minus square root 3 over 2. So we're not only including the positive square root 3 over 2, but the negative square root 3 over 2 as well. And then I'm going to do the same thing with my second equation. So add 5 to both sides. So here I have x is equal to 5. And these are my 3 zeros. Last one for E. I want to take out a greatest common factor if I have it. So I'm going to take out 2x because I can divide all of these by a 2 and an x. So then I'm left with x squared plus 3x minus 28. So 2 factors of 28 to add to 3. 4 and 7, and it should be a negative 4 because it's a positive 3. So 2x and then x minus 4, x plus 7. Set each piece equal to 0, so this gets equal to 0, this one and this one. So 2x is equal to 0. Divide both sides by 2, so x is equal to 0 is one of our solutions. For the second one, I would add 4 to both sides, so x is equal to 4. And then the third one, I would subtract 7 on both sides, so x is equal to negative 7. Those are our 3 solutions. So that's everything from the review. If you guys have questions, you can email me. If you email me before Wednesday afternoon, I'll try to answer your questions in maybe a video if it's something that needs to be worked out, but I could always work it out and email it back to you. So if you have questions before Wednesday, email me, or you can ask Miss Meadows and go see her before or after school Wednesday or before the test on Thursday morning. All right, have a great day.